Hello, everyone. Welcome to Theo-MathProblemSolver. And this episode, we are still continuing on the trig substitution. And in this particular problem, we want to find the area enclosed by the ellipse. And so the question is, how does, trig substitution come into play? So we'll take our time and we'll see how it comes out. All right, let's get going. So since we want to find the area uh, that is enclosed by this particular ellipse, what we kind of want to do is that we want to draw. Let's first maybe look at have a pictorial picture of what an ellipse looks like. Okay, so let's look at how an ellipse looks like. Okay, now a typical example of an ellipse will be like the egg. Okay, if you know an egg, if you have been eating egg, then you would know how an ellipse looks like. It just looks like an egg. Okay, so say this one I want us to open, stretch it on the x-axis. So by stretching it on the x-axis, we'll have something as this. Okay, good, good. So this becomes my a0. Okay, or b. The A is associated with the coordinate of X and then B relating to the Y. Okay. Good, 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 good. Now, now let's look at something. Now we have this particular ellipse. Let's maybe make Y the subject. Okay. So let's solve the equation of the ellipse for Y. So by solving it for Y, in which case you're gonna have Y squared on b squared equal to 1 minus s squared over a squared, okay? And when you simplify this a bit, you should be able to have a squared minus what? X squared or on a squared, okay? Good. Or if you want to further simplify that, you should have your y should be equal to plus or minus b on a root of a squared minus what? X squared. Okay. Good, 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 good. Now I want us to pay attention to certain things, because these things are very important as far as on our understanding of limits is concerned. Because the ellipse is kind of symmetric with respect to both, axes, the total area is 4 times the area in the first quadrant. Okay. So let's look at the area in this particular quadrant. Okay. So I want us to look at the area within this first quadrant. Okay. Does that make sense? So I want us to look at the area within this particular quadrant. That is the first quadrant, okay? And we said that the total area is always four times the area in the first quadrant, okay? Now, the part of the ellipse in the first quadrant is given by, so since we're in the first quadrant, remember the first quadrant, everything is positive. So in the first quadrant, I want us to pay attention that okay, the first quadrant, and I mentioned that the area that, let me say the total area, so that we said that the total area, okay, the total area is always 4 times the first quadrant, okay? The first is equal to 4 times the area of the first quadrant, area of the first quadrant, okay? So let's take note of that. So since we are in the first quadrant, remember that um, the solution will now becomes, or y now becomes b on a root of, let me just take my time to write it well. All right, so that's what we are having. Good. So now this is what we are having for the B. Now we also want to make sure that um 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 so now it means that my X will lie within this region 0 and A. Okay. All right. Now we see that X, since we're in the first quadrant, it means that X should lie between 0 and A. Okay. It should lie between 0 and A. Very important. So let's take note of that. So with that, we would have, okay, we would have, um, you know, 1/4 of the A equal to, okay, before we do that, let's look at it this way before I do that. So it means that my area will just be equal to 4 times, my area will just be 4 times the area in the first quadrant. Okay. And remember, we said that X is within the region of what, 0 to what? Within the 0 to A. Okay. Then B on A root of A squared X squared dx. Okay. Good, 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 good. So I can just decide to um go straight to the point. Okay. All right. So let's get going. Now we see that this expression in the as part of the integrand, the expression, so that we saw that the expression A squared minus X squared kind of send some message, send some message. And we said that anytime we have this expression, we can make a very, appropriate substitution. And we said that with this, we should have X to be equal to what? A hot sine theta. And this time around, our theta should what? Our theta, because we're in the first quadrant, it means our theta should lie between what? Our theta should lie between what? 0 and what? Pi on 2. Okay, because we're in the first quadrant. So take note of that. On a normal circumstance, there's no way we'll have this, range for theta. But because of, the appropriate change of variables, we want to do that. Okay, very good. Let's take note of that. But then, in as much as we want to go this way, remember that the problem we are looking at has a range in X. Okay, so has a range in X. So we want to take note of that. Okay, does that make sense? Okay, but then what is the X from this problem? What is the X from this? We know that our dx becomes what? A hot cosine hot theta d theta. Okay, good. But let's take note of that. Now, to change the limit of integration, we note that X start from 0, because when you look at the lower limit of the integrand is of the integral is 0. Okay, so when X is 0, what do we have for theta? So it means that we're going to have sine theta to be 0, in which case theta should be what? Should be 0. Okay, and when X is equal to A, what do we have? You should have what? Sine theta should be equal to what? Should be equal to 1, right? So which implies that my theta should be what? Should be pi on 2. So let's take note of that. Very important. So let's take note. Okay. But then we need to simplify this particular guy. So let's simplify this guy. So by simplifying this guy, we should have a squared minus what? A squared um sine square theta And when you simplify this a bit, you should have, remember that when we further simplify this, you should have something like this, okay? And when we also do some arithmetic, we should be able to have this, okay? Good, good, good. So let's get going. But just bear in mind that we have just like the way we solve previous problems, we also move from the x to the theta, the s community to the theta community. Okay. All right. Good, good, good. So let's get going. So therefore, we should have our area to be equal to 4 multiplying a on b, and which is which were given us this to be equal to, but remember, we made an appropriate change in the limit of the integration, okay? So it started from what, 0 to, I think it started from 0 to pi on 2. Okay, good. So it started from 0 to pi on 2, okay? Now, when we simplified this, we had what? A cosine theta. And and the x, we had what? A cosine theta theta, okay? When we further simplify this, we should be able to have what? For what? For AB. Then we have theta, that gives us what? Theta squared, theta d theta. Okay. Now, in algebra, well, we learned that, or in trig, which is in algebra, in trig, we kind of learned that a cosine squared theta is the same as what? Is the same as half 1 plus cosine this. Okay. So we want to employ the same idea here. Okay. So by doing so, so by doing so, our area should be equal to what? For A, B, all right. So we know that um cosine cosine squared theta is the same as what? Half of 1 plus cosine 2 theta. Okay. Now now we can pull out the half, and that when we pull out the half, it will cancel the 4, and that should give us something like this. Now the question is, when we integrate 1, what do we get? We have theta, and when we on the question we asked, if you had integrating some trig functions, we asked, so what function do we differentiate to get cosine? And that is what? Sine. Okay. But then you need to when we divide it by the coefficient of the theta, that is 2. Okay. Okay. Good, good. Then we have the appropriate limit as this. Does that make sense? Good, good. Now, when you perform your arithmetic, you should, especially with the interior, you should be able to have pi on 2, since pi on 2, since sine of sine 90 is 0, so you mean you don't have 0. Then when you sub in the lower limits, you should also have 0. Okay. Then in that case, you're going to have pi AB as the area of the ellipse of this particular ellipse. So this particular ellipse that we're given, the area that we had was, the area that we just got was pi AB. But let's look at this. Let's try and do some analysis here. Now Now we have shown that the area of the ellipse with semi axis A and B is pi AB. Okay. In particular, if we take, so let's do some room. Let me write this as a remark. For example, if we take A to be B, which is, let's name it as R as a popular name, R as the radius. Then we have proved the famous formula that the area of a circle will be with radius R is pi R squared. Now, if that's the case, then it means that my A should be equal to what? Pi. Now my A is R and my B is also R, which means I'm going to have what? Which means I'm going to have what? R squared, right? So now I've been able to prove the famous formula for the area of the circle R, the radius R, which is pi R squared. Is that not interesting? This is interesting. And at this point, if you have not subscribed, please do so. Like my content, comment, and share, and let's help demystify the myth around mathematics. So, guys, thank you so much for your time, and let's continue to help others. Thank you so much. See you later.